Inside me, there are two wolves. The first wolf says the other wolf is a liar, and the second wolf says the first wolf is telling the truth. If the first wolf was telling the truth, that would mean the second wolf was lying. But if the second wolf was lying, then that means the first wolf was also lying. This situation makes no sense, and is a prime example of a paradox. A paradox can be defined as a contradictory statement or situation. The two wolves inside me are a variation of one of the most commonly known paradoxes, the liar's paradox, which is the first entry in this iceberg. If you're not familiar with the concept of an iceberg video, let me catch you up to speed. Icebergs start with the highest level, which includes the well-known entries of a topic, but as the list goes down, you start to get into the more obscure and unknown concepts. So today, I'd like to introduce you to the insane and mind-breaking world of paradoxes. Before we start, I'd like to say that it's an honor that you're taking the time out of your day to watch my video, so thank you. With that out of the way, I'd like to start with the first level, the surface. The first entry on level 1 is opposite day. According to Google, opposite day is on January 25th. Every January 25th, kids will say it's opposite day, but in the process of saying it's opposite day, on opposite day, you're really saying it's regular day. It cancels itself out. The second entry in level 1 is the grandfather paradox. If you go back in time and kill your grandfather before your father was conceived, then he would never have been born. And if he was never born, you were never born. And if you were never born, you would never have had the chance to go back in time to kill your grandfather. Which means that in the end, nothing ever happened. The third entry in level 1 is Catch-22. This phrase comes from the book of the same name. In the book, a fighter pilot can be grounded for insanity, but the process of requesting permission to land proves he is sane. A popular example of a Catch-22 is when you need experience to apply for a job, but you need the job to gain experience. You're just screwed. The fourth entry in level 1 is the Ship of Theseus. Apparently this does count as a paradox, but if you don't care about this, skip to this timestamp. According to Greek mythology, Theseus was the king of Athens as well as an exceptional warrior who slayed the mighty Minotaur. He used a ship on many adventures and replaced its parts when necessary. This continued until every piece of the ship was replaced. The question is whether this ship can really be called the Ship of Theseus. If you collect the removed parts along the way and assemble them at the end, you end up with two ships. Which one is the real Ship of Theseus? This is a paradox of identity. It's identical to the common myth that the human body replaces all of its cells about every 7 years. The sixth entry in level 1 is the Pinocchio paradox. Everyone knows the story of Pinocchio. If he tells a lie, his nose grows, yada yada. The hypothetical here is, what if Pinocchio says my nose is growing? If he has not uttered these words immediately after telling a lie, then it's a lie. But saying this out of the blue will cause his nose to start growing, which transforms his initial statement into a truth, which stops the growth. But if it doesn't start growing, it's still a lie. Blah blah blah. You get it. Now that we're finished with level 1, we can get into level 2, which is far more interesting. The first entry in level 2 is the barber paradox. The barber of a small town has one rule for his shop. He shaves anyone who does not shave themselves. Seems simple enough. But when you look closer, there's a problem. Who shaves the barber? If the barber only shaves people that don't shave themselves, then he is banned from shaving himself. But if he doesn't shave himself, then he becomes a person who doesn't shave himself, which meets the criteria for someone he is allowed to shave. The second entry in level 2 is the Fermi paradox. The Fermi paradox refers to the discrepancy between the absence of evidence regarding the existence of aliens and the high probability that aliens are real. It goes, there are billions of stars in the Milky Way, and many that have planets within a habitable zone like Earth. Many of these stars and their planets are much older than Earth by billions of years, and since intergalactic travel only takes a couple million to achieve, logically, we should have already made contact with them, or they made contact with us. The paradox comes from the fact that this is yet to happen. The third entry on level 2 is the Raven paradox. This is a logical paradox and usually is comprised of 4 statements. The first, an observation. all ravens are black. The second, an inverted version of the first statement. If something is not black, then it is not a raven. The third, a personal anecdote to support his theory. My raven is black. And the fourth, a totally irrelevant statement that does not support his theory. This green apple isn't black, so it's not a raven. This paradox comes from the implication that you can acquire information about ravens based on the color of an apple. It relies on conditional statements that tie blackness with ravens, assuming they are mutually inclusive. Ultimately, it boils down to the fact that this guy tried to make observations on ravens by looking at an apple. This was made in like the early 20th century, so I guess this guy was just bored or something. The fourth entry in level 2 is Hilbert's Grand Hotel. This is very famous and you've most likely heard about this. Imagine an infinite hotel with an infinite number of guests is completely booked for the night. A person walks into the lobby and asks the bellman if there are any rooms available. The bellman says no, but not wanting to kick the person to the streets, thinks of a solution. He relocates the person occupying room 1 to room 2. Then the person in room 2 to room 3, the person in room 3 to room 4, and so on. Since there's an infinite number of rooms, there isn't a definite ceiling to how many rooms may exist. So making up space in room 1 is no issue. This can be repeated for however many guests check in for the night. Crisis averted. But what would happen if an infinitely large bus with a countably infinite number of passengers asked to stay for the night? His solution for this? He moves each person into a room 2 times the number of their current room. The person in room 1 moves to room 2, person in room 2 moves to room 4, person in room 3 moves to room 6, and so forth. By doing this, he fills all of the infinitely even rooms and empties all of the infinitely odd rooms to accommodate the infinite bus. The way our brains perceive something as large as the infinite is just counterintuitive. No matter how many crazy hoops we force the bellman to jump through, there are still an infinite number of occupied and vacant rooms. The fifth entry in level 2 is Schrodinger's cat, another very famous paradox. It's a thought experiment where you place a cat into a box for an hour that has a 50% chance of killing the cat. At the end of the hour, is the cat alive or dead? That's the question. Schrodinger argued that this was irrelevant. The results will be the result no matter what, but what happens before we open the box is what we should turn our attention to. Before the box is open, the cat is both equal parts dead and alive. It is only revealed to be one or the other when the box is opened. This relies on a phenomenon called superposition. It's a part of quantum mechanics and is so insanely complicated that it made the creator of this entry, Erwin Schrödinger, change career paths from this quantum stuff to biology. The sixth entry in level 2 is Baby Hitler. It's another time machine one. If you went back in time to kill Baby Hitler, you would not have committed all of those atrocities, so you would lose all motivation to go back in time to kill him. The seventh entry in level 2 is the crocodile paradox. In this scenario, a crocodile kidnaps a kid. The mother pleads for the release of her child and the crocodile accepts, but on one condition. The mother says, "I'll do anything, just let my baby go." The crocodile says, "I will return the child if you can guess whether I will return the child or not." From this, there are 4 possible scenarios. The first 2 include her guessing incorrectly and saying bye-bye to the kid. The third is her answering, "Yes, you will return my child," which coincides with the croc's intention, leading to the boy's release. Ooh ah, happy ending. The fourth is when the paradox comes into play. She answers, "You won't return my child," and answers correctly. Since you guessed correctly, the child is returned, which means he returns the child. But since you guessed the right answer, it causes a chain reaction which leads to your guess being incorrect. Let me break down the course of events on the fourth option. If the croc won't return the child, and the woman answers, "You won't return the child," then she's given the croc the right answer. So, the croc is forced to return the kid. But by the process of returning the kid, she is ultimately given the wrong answer, which forces the croc to keep the kid, even though she's made the correct choice. There's simply no way to win this scenario if the croc doesn't want to return the kid. To be honest, I don't like the crocodile paradox at all. If we're being picky about the fourth option, aren't we being picky about the third option as well? It's pretty much the exact same principle. but people only focus on the fourth one for some reason. The paradox is also worded in a way that feels impossible to understand on first read-through. But maybe I'm just dumb, I don't know. Well, let me know what you guys think. Moving on to level 3. The first entry in level 3 is the Abilene paradox. It states that people can make choices based not on their desires, but their presumption of what everyone else desires. Then, they will unanimously agree to do something that no one wants to do. For example, if everybody in a group wants to watch Minions 2, but they think that everyone else wants to watch, say, Harry Potter, then everyone's just gonna say, let's watch Harry Potter, when no one wants to watch Harry Potter. The second entry in level 3 is the paradox of choice. A woman browses the jam aisle and is delighted to see hundreds of flavors to choose from. She ponders for a while, then chooses a jar. Once she puts it in her cart, her eyes dart towards a better flavor, so she chooses that one instead. As she is exiting the aisle, she reaches the edge and comes across, you guessed it, an even better jar of jam. The next day, she makes some toast for breakfast. Her family loves the jam, but as her teeth meets the jelly, she wonders if this was the best the store had to offer. Big selections of goods will yield better results for the consumer in theory. They get specifically what they think they want. However, the large selection also leads to greater anxiety, indecision, and inevitable dissatisfaction when they leave questioning if they made the correct choice. The third entry in level 3 is the Grelling-Nelson paradox. It was thought of by Kurt Grelling and Leonard Nelson in 1908. Heterological means a word that does not describe itself. By this definition, the word heterological is heterological. That is the end of the Grelling-Nelson paradox. The fourth entry in level 3 is the hedgehog's dilemma. During the winter, hedgehogs will huddle together to keep warm, but must remain wary of one another so as to not prick one another with the sharp spines Mother Nature gave them. This dilemma was created by German philosopher Arthur Schopenhauer. The hedgehog's dilemma is a metaphor describing the double-edged sword that is intimacy. It's also the name of the fourth episode in the anime Neon Genesis Evangelion. The fifth entry in level 3 is Unexpected Hanging Paradox. This paradox was first published in a magazine in 1963. A judge tells the death row inmate that he will be hanged at noon on a weekday sometime next week, and it'll be a surprise. He doesn't know the day, he just knows that the executioner will knock on his cell at noon when the day comes. He thinks about the sentencing and comes to the conclusion that he will not be executed. His reasoning is peculiar. If he isn't hanged by Thursday, then no matter what, he'll be hanged on Friday. But it wouldn't be a surprise, which is a vital condition of the judge's sentencing. So, he concludes he cannot be hanged on Friday. He then speculates that a Thursday hanging is also out of the question, since it can't be Friday, and if he isn't hung by Wednesday, it must be a Thursday hanging, which comes at no surprise. He follows this path of logic and realizes that by her conditions, it can't happen on Wednesday, Tuesday, or Monday either. He sits back in his cell relieved that the crisis is over. At noon on Wednesday, he hears a knock at his cell. The sixth entry in level 3 is Predestination, the final time travel one, I promise. A guy goes back in time to discover the mystery behind a fire. While investigating, he knocks over a kerosene lantern that starts a fire, the very fire that caused him to go back in time in the first place. Unlike the other two time travel entries, where the cycle seems to have no end, this cycle seemingly has no beginning. The seventh entry in level 3 is the Penrose Triangle, aka the Impossible Triangle. It is an optical illusion that cannot be created in a physical space, since it is bound to the second dimension. The triangle is in fact geometrically impossible. It tricks your brain's depth perception into seeing something that simply cannot exist. The eighth entry in level 3 is the
Bhartrihari
paradox. He was an Indian thinker of the 5th century and said if there are unnameable things, then they are classified as being unnameable, which is, in a way, a name. That is the final entry of level 3. Moving on to level 4. The first entry in level 4 is Galileo's concept of the infinite. The guy that created the telescope proposed that there has to be more numbers total than square numbers. If you forgot what square numbers are, they are the results of multiplying a number by itself. For example, 1, 4, 9, 16, 25, 36, 81, you get it. If you thought surely the total amount of numbers was bigger than the amount of squared numbers. However, since there's an infinite amount of square numbers and all numbers, one cannot be bigger than the other. This entry kind of acts like a precursor to the Infinite Hotel, since Galileo thought of this hundreds of years before the Infinite Hotel. The second entry in level 4 is Sorites paradox. Suppose that there is a heap of sand, not a mound, but a heap, specifically a heap. If you take away one grain, it's still a heap of sand, but take away one grain enough times, then you will ultimately be left with a single grain of sand. Could that grain be considered a heap? If not, when did it stop being a heap? The unclear transition from heap to grain and the seemingly impossible solution to this is a paradox of vagueness. It's unquantifiable, like what Draymond Green does for the Warriors. The third entry in level 4 is the paradox of enrichment. The paradox of enrichment is a term coined by Michael Rosenzweig in 1971. This phenomena occurs when prey are given an abundance of food, which causes their population to skyrocket. Their populations aren't the only ones skyrocketing, since the predators are then also presented with an abundance of food. In many examples, the predator will overhunt the prey to unsustainable levels, often extinction, and with no other food sources available, the predators will starve themselves out. Artificial destabilization of a perfectly balanced predator-prey relationship is at the crux of paradox of enrichment. The fourth entry in level 4 is Olber's paradox. It's a cosmological question that asks why the night sky is dark when the universe is filled with infinite stars. Shouldn't the stars illuminate all of the dark spaces in between our night sky? The question was made under the assumption that three things were true. The universe is 1, infinitely old, 2, static, and 3, large. The creator of this paradox, Heinrich Wilhelm Olbers, observed and wrote about this contradiction in 1823. The science of his time explains why he wouldn't know and would be curious about this. Today, we know that the universe is ever expanding, and the light from many stars have yet to reach our planet. And should light from very, very far away stars ever reach our planet, they will undergo redshift, a process in which the wavelength of light is stretched to the red end of the color spectrum, which is at times invisible to the human eye. The fifth entry in this list is the Banach-Tarski paradox. The only thing I have in my notes here is to watch the Vsauce video. The sixth entry in level 4 is the coastline paradox. This paradox describes an effect where the perimeter of a coastline is determined by the unit used to measure it. If I measure the perimeter of a coastline by, say, 100 miles, then use 100 mile sticks to roughly measure the coastline, by using 28 of those sticks, the coastline will be 2,800 miles long. If I replace that stick with a 50-mile stick and measure that same coastline, the coastline comes out to 3,400 miles. Then, replace that stick with a 1-mile stick, and the coastline measures to 8,000 miles in its perimeter. This can go on forever. This is because coastlines are in fact fractals. A fractal is any pattern that looks the same on any level of zoom. Because fractals have no defined border, they are technically infinitely large and impossible to ever accurately measure. That is the last entry of level 4. Moving on to the final level, level 5. The first entry in level 5 is the birthday problem. It's the theory that if you take a group of 23 random people off the street, the chances of 2 people sharing the same birthday is over 50%. With 23 people in the room, there are a possible 253 pairs that can be made from that. Theoretically, this makes sense. 250 pairs in only 365 days, there's a good chance that works. But that's not how it works. The probability of someone's birthday landing on any specific day is 1 in 365. I count 2 people, so it's 365 times 365, which is 1 in 133,225. So the chances of 2 people having the same birthday within a room of 23 people is 253 over 133,225, or 0.02%. This paradox sucks. It's hands down the worst entry on this list. The second entry in level 5 is Buridan's ass. The donkey is starving to death. He's exactly midway between 2 stacks of hay. The scenario assumes that the donkey will choose the closest stack, but since they are equidistant, the donkey is paralyzed by the choice, spends too much time deciding which bale to go for, and dies. The third entry in level 5 is Bonini's Paradox. This explains the difficulty in making models or simulations that are accurate and useful. Sounds kind of boring, but it's pretty funny actually. The phenomenon has been described by experts as the more complete a complex model becomes, the less understandable it gets. An extreme example of this is if a war general were to utilize a map that is one-to-one to his battlefield. Although it is incredibly detailed, it's basically useless. The fourth and final entry in level 5 and the iceberg as a whole is the Mpemba effect. It is the fact that hot liquids or colloids can freeze faster than cold ones, even under similar quantities and conditions. A Tanzanian student asked his professor when two equal volumes of water are placed in a freezer, one at 35 degrees Celsius and one at 100 degrees Celsius, why does the hotter one freeze quicker? Intrigued by this, the professor went to work with the student and confirmed this theory, ultimately publishing it in 1969. People have theorized that this is caused by supercooling, a phenomenon in which water reaches temperatures below its freezing point, but refuses to crystallize. This would be a pretty neat explanation, but unfortunately, the Mpemba effect is incredibly difficult to recreate since there are so many variables at play. If you made it this far into the video, thank you so much for watching my stuff. I really appreciate it. Sorry that the last entry was pretty boring. The Mpemba effect was like super just lame, but it's like it's an iceberg video. I have to include all of the entries on the iceberg, you know, or else it wouldn't make any sense. If you enjoyed this video and want to see more like it, please consider liking and subscribing. Anyways, have a great rest of your day. Bye-bye.